and welcome to the video demo of our project called the Software Similarity Program. I am Matthew Sabularse and my partner is Kenley Chiu. So to start, our program has two controllers. The first one is the main controller and the second is the interface controller. So if we hit run, this will launch the program, and this is the user interface of the program. The very first step that we need to do when we want to start our program is to retrieve files from the GitHub. These files are actually repositories for each pair in the class. So if we head over to the codes folder, this is the this is a project, and if we head over to the codes folder, this contains all of the pairs that will be used during comparison. So as of now, these are actually garbage files because let's say I downloaded them a week ago and I wanted an updated version. So if I were to click retrieve GitHub and go back, these folders have been deleted and are going to be replaced by updated folders taken directly from GitHub online. So right now it's downloading all of these files. And the way this downloads is if we head on over to file handling, the the program executes a Python file here called repo grabber, and this file essentially is the one that takes the files from GitHub and downloads them locally. So while all of these files are downloading, I'd like to discuss all of the features of the program. The first feature are being able to decide which file types you want your program to consider. So on the left side, if we look over here, we can choose either Java files only, C++ files, or other file types. So if in case we didn't want Java or C++, we could just use Python files. So if we were to click the others checkbox, the text field at the bottom would become visible, and then we can just type in py or p. So we don't include the period when we want file types. And then for comparison below that, we have two ways to compare files. The first way is by line and the second way is by string. Then below that, we have an option if the user wants to save all of the rankings per comparison in a text file. So when you click that option, again the text field below it becomes visible and then you can type the file name. And when typing the file name, we have to exclude the .txt um, suffix at the end of the file name. And then at the top, if we wanted a custom folder file path for a folder containing files, we would have to just copy and paste the directory or the file path basically. But since this is empty, and then if we click compare, then it will use the folder codes as the default folder to use files for comparing. And then on the right hand side, we have the top 10 similarity scores table, or it's basically a list view that displays the top 10 highest similarity scores. The way that we were able to do this is we used a quicksort algorithm to sort all of these comparisons, and not only does it sort them not only does it sort the percentages or the scores, it also sorts the name of the pairs. So the name of the pairs will be seen here. Below that, we have, of course, the quit program button, and then we have a status label. So for every action that is being done in this interface, it will appear here. Such as now, it says retrieved all repositories. This means that all of the files have been completely downloaded. These have been finished downloading, and they can be now used for comparison. And then below that, we have the longest similar string label. This is essentially the label for the longest similar string compared by each file in the program. So to start, let's say we would want to compare. Let's say we would want file types of only C++ and we would want to compare them by line. So we would hit the compare button. And this actually takes a long time. If we choose all of the file types, it will take longer just because there's so many files and so many folders that the program traverses and then reads and then computes basically. So right now, we have all of the values taking into consideration only C++ files from each pair. As we can see, the diagonal diagonal um, trend here basically means that for this pair, it's being compared by itself. That's why it gives off a similarity score of 1, or which means 100%. And then on the right hand side, we could see that the highest percentage value is 99%, and then the 10th highest is 85%. So if we want, and then we could see the longest similar string here at the bottom, which is string file names, and it goes longer than that. And yeah, so if we would want, let's say, only Java files, and then we would compare them by string, and we hit compare, which takes longer because there are more Java files than C++ files present in the class repositories. And here are the values. So we could see that the top 10 similarity scores have been updated, the lowest being 0.64 similarity score. And yep, this has more value since there are more Java files and C++ files. And we could see that the longest similar string has not changed because that means that the comparison the longest similar string being compared has been executed properly basically, from whether it's a line comparison or a string comparison, it's both the same. So if you would want both files, so no, let's say we click others and then we click C++ and then others we type Java. This basically means that we're using both files to be considered. And then let's say we would want to save this into a text file for ranking. So let's call this string comparison using all types. And we hit compare. And now it's loading. And while it's loading, I'd like to discuss how all of this is being compared. So essentially, the program runs through all of the files, all of the folders, and then all of the files. So let's say for pair 1, let's go to codes and we go to pair 1. There's several files in here. We could see that the folder contains folders. So basically, we use recursion to go through all of these folders and every file, and then it will take each of those files and then concatenate them into one whole text file that will be used for the comparison. It's basically a master text file. So if we go to merge codes, this means that there's only 19 items in here. And in the first pair, let's say for pair 1, this contains all of the lines of codes seen in the folder, in the codes folder. So basically, it's for taking into consideration multiple files of a program, because there are programs that have only one file, but majority of programs have several files, so we need to consider them as one file. So right now, all of these files have been done, being compared, and now we could go to the logs folder, which contains all of the text files, and then we could see that we have generated this string all text file, and this contains all of the comparison data that has been generated in the program. So we could see the first one, it started off with pair 12 and pair 17, and it gave off a score of 85%. Oh, actually, all of these files all these comparisons are sorted from highest to lowest actually. So whatever the output of whatever the output is from the quick sort algorithm, it has been written into this text file basically. Then, for example, we would only click others, and then we would want to compare. It should give the status that the others text field is empty. Likewise, if we would want a text file for rankings, if we leave that, and I closed it by accident. But essentially, if we leave that text file, the text field for the text file empty, hit compare, that means it will say enter a text file name. So it's basically returning an error that users would might accidentally encounter. And then if we go to the metrics tab, we could have a folder path. We have a folder text field which takes in a file path of the folder that you want all of the files to be considered, or just a folder inside this program, this project, basically. So let's say we would want to use the src folder. We would have to copy and paste the file path into this text field and then hit compute. The table on the left side is basically, it uses the local function that we have made to generate data for the software metrics. And then on the right side, it's a table which displays the values that have been generated by using an API, which is the Halstead, which is basically just a comparison, because the Halstead API is a more accurate way to generate software metrics. And then at the status, it says metrics generated. So we we could actually just use a folder here. So if I were just to type src, we could see that both values have not been changed. But just note, the Halstead API only takes into consideration Java files, whereas the local function takes in whatever. And now I would like to discuss how these files are being compared, how these comparison scores are being achieved. So for the first one, for reading the code by line, basically it stores the first program, all of the lines in the first program and all of the lines in the second program into two array lists, and then it checks if, and then basically if the program line is not empty, then add this into the array. If the second if the first line of the second program is not empty, also add it into the array. So basically, these two if statements before the else statement, it considers if one file has more lines than the other file. So let's say the first program has 60 lines, the second program has 70 lines. The program's not going to stop adding lines into the array once it hits 60, since that's the max number of lines in the first program. It will keep adding until all of the lines in the second program have been checked and added. And then in this nested for loop, this is where the comparison starts. It will look for the it will look if the line in the first array at the same index is equal to the line in the it will check if the first line in the first array equals the line in the second. Basically, let's say the first line in the first program is going to be compared to the second program. It will check if that line is in all of the array is present in the second array. So basically that means in a program, a line can appear in, let's say a line appears in line 50 in the first program, and then in the second program it appears in line 70. So basically, to compare if that line is in the second program, we have to traverse all of the lines in the second array. And then after that, it will set the boolean to true, which means if we go to program line, it means that that line has been compared. So when that line has been compared, it will take it out of the array list, and then it won't consider that line to be checked so that there's no repetitions. And then to get the percentage, we get the amount of same lines divided by the amount of total lines. And then for reading the code per string, first it splits all of the strings and stores them into an array list, which happens over here. And then it checks which code has more strings so that it would be the total count. It will go into a while loop if j is less than the size of the first code. Then there's a for loop which is until the size of the second code. So if the string of the first code and the second code have the same string, then it will remove them from the array list. And then it will increment j until all of the strings have been compared to. And then the percentage is the same amount of strings divided by the total amount of strings. And then here, for how the files enter the matrix over here, it's basically a nested for loop again. And since this code is dynamic, so if there are only 10 files, that means it's only going to give the matrix of a 10 by 10 matrix, essentially. So we use this matrix class where the master matrix is a 2D array list where we have a temporary array list which stores the first value, the temporary value, and then stores this into the matrix. Then yeah, like I said, for getting the files, it uses recursion. It checks if the file is a directory, and then if not, it will it will read that file, and then yeah. Now the next thing I would like to discuss is how it's being displayed in the GUI, in the user interface. So if we go to use interface controller, basically in the fxml file of this program, this is a scroll pane. This thing is a scroll pane and an anchor pane. There's no grid pane here. So we have to create the grid pane first and then add rows depending on the amount of files, or depending on the size of the matrix. Basically, we add rows and then we add columns, and then after that we create we use the class data object, which is basically a data object containing, if we go over here, it contains the data, the similarity score, a label, which which is the username, and then a vbox, so that this will be the node put into the grid pane at a certain row and at a certain index. Then for for the for the metrics, basically the local function that's being used is this search operations and operands. So for the local, it only considers all of the operations that we have handpicked, whereas using the API, it's automatic. It searches all of it. But for the local, we considered operate all of the common operations and operands. So the way this works is it reads the program per line, and then it compares each character to all of the if statements here, such as this one. If the character at a certain x index is equal to the equal sign, then we have a certain counter for that equal sign, and then will be displayed in the console to show if our data is accurate. Over here, operators, number of periods, number of parentheses, number of if statements, so on and so forth. And then to compute for each software metric, there are certain formulas, but basically they're interconnected. So one software metric can use the data of another, the output, the result of another software metric. And the last thing that I would like to discuss, it would have to be the over here in the generate scores tab, generate scores functions. So this is where all of the files are being sorted using the quicksort algorithm. If we go to matrix and we go at the bottom, this is where all of the files are being sorted using the quicksort algorithm. And when they're sorted, they are reaccessed back in the similarity in the generate scores function. And then to display them in the GUI in the list view of the top 10, we just have to get the first 10 values in that array list. But of course, if that means if there are less than 10 files, if there are less than 10 files in the folder where we have compared the files, then it should only display the number of files. For example, if there are only 5 files, that means it should only display 5 files in the top 10 list view. It's indicated here. So in this for loop, so if I plus 1 is greater than the size of the matrix, then we have to break the for loop. And I would like to conclude the video demo for this software similarity program by quitting the program below. Thank you for listening.